Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 293. The problem name is largest combination with bitwise and greater than 0. It's a medium level problem. So first the problem says what is a bitwise and for a given array. So suppose we have an array 153, then the bitwise and will be equal to 1 and 5 and 3. That comes out to be 1. And suppose we had just have one number in the array, so the bitwise and will be the same number. So it tells what is the bitwise and. Now the problem statement says that we are given an integer, an array of positive integers candidates. Now we need to evaluate the bitwise and of every combination of numbers of candidates. So suppose we have n elements, so we will have 2 raised to power n combinations. So for every combination, we need to compute the bitwise and each number and candidate may only be chosen once in each combination. Yeah, so obviously for every combination we can choose one number only once in that particular combination. We need to return the size of the largest combination of candidates with a bitwise and greater than 0. So among all the combination that we have chosen, some will have bitwise and greater than 0. So among those filtered combinations, we need to return the maximum size of the combination. Let's try to understand it with the help of an example. So this is the array, and if we choose the combination 16, 17, 62, 24, we get the bitwise and to be 16, which is greater than 0. So the size of the combination that we have chosen is 4. There could be other possibilities. We can choose these 4 elements. Again, this will result in 8, that is greater than 0, but again the size is 4. So we can choose any combination. We just need to return the size. Also, it can be shown that no combination with a size greater than 4 has a bitwise and greater than 0. So that's why we return 4. The second example says that we have 8 comma 8, and the largest combination, obviously we can take both the elements. Like we can choose the combination which has both the elements, and the bitwise and will be greater than 0, so we return 2. That is, we have chosen 2 elements. The constraints are we can have 10 raised to the power 5 elements, and each element can go up to 10 raised to the power 7. So these are the constraints. Now let's look how we can approach this problem. Uh, so let's first see what. So the constraint says that we have 10 raised to the power 5 elements. So total 2 raised to n combinations will be there. That is 2 raised to 10 raised 2, 2 raised to 10 raised to 5. Now that is a very big number. Obviously, we will not be generating all the combinations. So what is the other way that we can look into this problem? Now the other thing that the problem says is that a number can go up to the maximum number that we can have is 10 raised to the power 7. Now this bigger number can be represented by 24 bits. Like if we represent this number in binary format, so we will need 24 bits to represent this number. So now what we can do is that let's look into an example of how we can approach this problem. Suppose we have some numbers. Suppose we have some numbers represented in binary format. Let it be 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1. Suppose these are three numbers, number 1, number 2, and number 3, and we have represented these numbers in binary format with this being least significant bit, that is the 0th bit, this is the first bit, and so on. However, it doesn't matter, but the order of the bits doesn't matter. But let's see. Now, suppose we want to make this particular bit. If we do AND operation for all the numbers, so suppose we want to make this particular bit position as 1. That means we want to AND numbers such that this position returns 1. So what will happen is that we will not choose this number, the last number. Why? Because in AND operation, no matter how many ones you have, even a single 0 will make the result as 0, right? So that means if we choose this one and this one, we skip this one. So that this 0, sorry, this 0, that means we have chosen two numbers and we get a value greater than 0 uh, for the AND operation. Now it doesn't matter what are the numbers present here, because we have chosen these two numbers. This result will give us 1. It doesn't matter even if these things give 0, because suppose this was 0, so AND operation would have given 0, this also 0, this also 0, 0. Though these would have given us 0, but this gave us 1. And the question says that we need to consider the numbers, the combinations which have AND operation greater than 0. So for every particular bit, if if that particular position is giving us value greater than 0, then the resultant will also give us value greater than 0, because if for the selected numbers other bit positions are returning 0, then also this position has 1, so the total value will be greater than 1. Now let's see some other positions. Suppose we consider this position, that is the first position. So here you see, if we want to make this position as 1, the resultant, we need to select numbers such that this position returns us 1. So what we'll do, we select this number and we'll select this number. We'll not select the first number because the AND operation will give 0 at this bit position. Now we want to make this bit position as 1. So we select these two numbers and then we get 1. Obviously we want to select the maximum number of ones that we have. That means the total number of ones, because we want the combination size to be maximum. So this will give us a size of 2. Now suppose there would have been a case where, like suppose this would have been 1, this would have been 1. So we have all three numbers having 1 at this bit position. So if we selected all these three, the resultant would have been 1 and we would have selected three numbers. So here we selected two numbers for this bit position. For this bit position we selected 3. For this bit position we selected 2. And for this bit position we selected 1, because we have only one. For this bit position also we selected 2. So the maximum of these is 3. So that's why we return 3 in this answer, because we can select three numbers, we can select all the three numbers, and this particular bit position will return us 1, and the resultant will also be greater than 1. So this will have the maximum size. So this is the approach that we will follow, that for all the numbers, for all the numbers we'll see that how many ones we have at a particular bit position. Like suppose these are 24 bits, then for how many at a particular bit position, how many ones do we have in all the numbers. Like for if we consider the first position, how many numbers have one at this position, how many numbers have one at this bit position, and so on. And all we need to do is that we just need to return the maximum number of ones that we have, because for that bit position we can select those numbers from the array to get a result greater than 0. So this will be our approach to solve this problem. Uh, Generally, bitwise problems are a little bit tricky. Like we can see here, we don't need to calculate the combinations here. Just representing the numbers in the form of bits will give us the answer. Let's look into the implementation. So this is the frequency array that I was talking about. This will keep that we have taken a size of 24, because the number will be represented by 24 bits. So every position will hold that how many numbers have one has one at this particular bit. And now we start traversing the array. This is the current number that we are considering. We are trying to fetch each and every bit from the number. So while current number is greater than 0, if the current number obviously if the last bit is 0, sorry, if the last bit is 1, increment the frequency at that particular position by 1. So this is the counter. From j equals to 0, it can go up to maximum j equals to 23, because we have 24 bits. We increment the j, we divide the number by 2 and we do it. So finally for all the numbers we'll have the frequency at a particular bit, and then at last all we need to do is that we can see that uh, what is the maximum number of ones that we can have at a particular position, and we just return that in the form of our answer. So this is the solution for this problem. I hope that you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel and add any comments if you need more clarification on some of these concepts. And yeah, see you in the next video. Take care. Bye bye.